Okay, so this will be the prep video for section 2.6, which is on differentials. I have found that actually part of the problem with this section is not the calculus, but the algebra, because there's some notation that typically people aren't familiar with. So this prep video is not really going to touch on the calculus very much, but just to try and get a solid grounding on the algebra component to it. So first thing we need to think about is slope. We know that average slope that's our algebra concept. Average slope is change in change in y divided by change in x. And the notation we're going to use for that is delta. If you've taken chemistry, you'll recognize that. A lot of times we use that with temperature. So change in y divided by change in x. So delta we just read as change in. And this is a finite number. It's a fixed amount. We also remember that instantaneous slope is the slope at one point. It is our derivative, and so we write that as dy dx. Look at these. They're really very similar, right? So delta is a fixed finite amount that you can write down. Dy dx, remember, that's when the points have gotten so close together that they're essentially one point. And so the d is smaller than the delta. That's kind of the thing to remember. Okay, so you might wonder why I've drawn this on the board ahead of time. It's because I needed to make sure to get it right so that I could show you what I need to show you. So let's find some things based on this graph. So this graph is the graph of y equals x squared plus 1. So the first example we're going to do, actually, before we get there, let me write out a little bit more about this. We're going to introduce differentials. And before we can introduce those, that's the calculus concept. The algebra concept is increments. And that pertains to this delta. So if I have an x1 value and an x2 value, and we kind of make x2 the second point, so there is some order to this, just like there is when we find average slope. In fact, let's go ahead and write that out. We would write y2 minus y1 divided by x2 minus x1. So this tells us right here how we connect x1, x2, and delta x. So this tells us that delta x is x sub 2 minus x sub 1. Or if we turn that around, we can write, if we add x1 to both sides, we can say that our second point is our first point, x1, plus whatever the change was. Okay? And then, of course, we can do the same thing for y. It's the mirror image for y. So if we have y1 and y2, then delta y is just the difference, y2 minus y1. And again, we can get to our second y if we start with our first y and then just add the change. Okay, so now we're ready to tackle this problem. So what I'd like to find first is I'm going to give you some x1 and x2 values, and I'd like to find delta x, delta y, and the average slope. Okay, so let's start with x1 equals 1 and x2 equals 2. So the first thing we're going to find is delta x. That's just the difference, 2 minus 1. And now we need to find delta y. So delta y, remember, is going to be y2 minus y1 to correspond to the x2 minus x1, which means we need to find those values. So y2, x equals 2, so y would be 4 plus 1 is 5. y1, x equals 1, so 1 plus 1 is 2. So delta x is 1. To go from x equals 1 to x equals 2, we just jump by 1. And then y goes from 2 to 5. So now we know that delta y over delta x is 3. So if we were to actually, if we could connect this with a straight line that you could see was different from the graph, we'd see that it has a slope of 3, just connecting those 2 points. Okay, so what if I gave you a slightly different problem? What if instead of this setup, I gave you the starting point and the change? Well, now I already have this. I mean, let's back up. If I'm trying to find delta x, delta y, and the average slope, I already have delta x, that's 1, okay? So now I'm looking for delta y, y2 minus y1. Well, I have x1, so I know y1, so I know this one is 2, but I don't have y2 because I don't have x2. But can I get x of 2? Absolutely. We know that x of 2 is just the starting point 1 plus the change that occurred, another 1, 2. So really this is the exact same problem as the one we just did. It's just a different setup. So you can either be given x of 1 and x of 2, or x of 1 and the change in x, which then you can add to find your second x point. So the thing that I wanted to introduce, this is the algebra component. The part that people get stuck on a little bit is this delta. I want to allude a little bit to what we're going to do with the calculus. Remember I said if you could connect these two dots, right, you'd have something with a slope of 3. What calculus is going to say is, these two are really close. D is smaller than delta, but if delta gets really, really small, then it's pretty much kind of the same as the derivative. So what we're going to do is, I'm trying to draw a tangent line. I don't know how well I try this again. Trying to draw a tangent line right here at this point. And you can see that it's not quite the same as the actual value, right? It's a little bit different. And so what I'm trying to show you is that we can use algebra to find the exact slope between those 2 points. But we could use calculus to estimate. If I know the derivative here, that means I know the slope, and I can say, well, if things continued along that same pattern, I could just go out on that slope line, that tangent line, and find my approximation. And so that's what we're going to do in class next time. So I guess that's it. What you'll have for assignment is mostly working with this, but just know that this is where we're going with calculus.